All right, welcome everyone. Happy today to have Julie Barnum presenting as part of the Python and Heliophysics community. So Julie is the lead for the Python and Heliosphere community, PyHC. She is passionate about leading and facilitating technical work and group efforts across organizational and cultural boundaries and building relationships within communities in the process. Her interdisciplinary background is fitting for this kind of work. She comes to the PyHC community with a Bachelor's of Science in Applied Physics, a Master's in Science in Atmospheric Science, and experience working with several space missions, software, and community projects. Outside of her work, you'll catch her dancing, especially to hip hop music, sharpening her non-English language skills. She's conservationally fluent in French, and partaking in just about every outdoor activity one could do in Colorado. So with that, Julie, I'd like to pass it on to you to talk about PyHC.
Hi, thank you. All right, let's share. Okay, are you seeing the normal slides?
Yeah, I've got full screen view.
Perfect. Awesome. Well, thanks everyone for having me today at this MOS seminar. As was mentioned, I'm Julie Barnum. I work at the Laboratory for Atmospheric and Space Physics, which is partnered with the University of Colorado Boulder. And today I'll be talking to you about the Python and Heliophysics community, or as we call it, PyHC. I'll start off with a bit of an overview of the community as a whole, and then go through some recent activities in the past year or so. So the motivation behind PyHC is simple. At the beginning of all of this, before PyHC formed in 2018, there were several different Python development projects in the works, but not necessarily a whole lot of talking between projects at the time. And as a result, there were several, overlapping needs between projects that weren't being addressed because people didn't know that they needed to be without communicating. Also, a lot of the code had varying standards from, just being kind of one-off siloed projects to full-fledged communities of developers actively working on a project. There were varying stages of development as such between projects. A lack of organized information about existing code, because how can you know about something if everyone isn't talking to each other? A potential need for generic libraries across projects to help with those overlapping needs, and just in general, a general need for communication. So as a result, we decided to create a community that would address these issues, or otherwise known as PyHC. So in order to kind of steer this PyHC ship, we came up with some strategic goals at the very beginning of all of this, I think at our first biannual meeting that we ever held at last. So we wanted to promote efficient interdisciplinary research, promote scientific reproducibility and software sustainability, promote best practices for software development, documentation, testing, and dissemination of information. We wanted to foster an open source Python software ecosystem for heliophysics research and education, both education for current scientists as well as those early career or still in school. We wanted to foster educational and support base for the Python user community in the solar and space physics realm. We wanted to foster an increased community awareness of and participation in projects, especially inter-project work. We wanted to also foster a space just in general to share lessons learned between developers. And finally, we wanted to be sure that we were identifying and pursuing opportunities for financial support, be that to continue our community, for individual projects, for bigger inter-project work, and so forth. We wanted to identify community needs for future development. And finally, of course, find ways to coordinate development across projects to minimize duplication of effort. So with all of those strategic goals, we put into action our plan for PyHC. So we do a lot of different things throughout a yearly basis, including our biweekly telecons, which I say biweekly, but it's about every 2 to 3 weeks as schedules, meetings, holidays allow. And these telecons, we have a bunch of different topics that are discussed therein. Sometimes we have project intros and updates for current projects or projects that are interested in becoming part of PyHC. We have continued discussions from our biannual meetings, from past telecons. We'll have outside speakers come and talk on topics that are relevant to the community and so forth. We've participated in AGU every single year that we've been a community. The past few years have just been virtual because of the COVID-19 pandemic. But before that, we did have some in-poster sessions. This year, we're really excited. We're going to have both in-poster person sessions and finally an oral session. So be sure to check us out at AGU if you're going. All of our activities will be on the Thursday of that week. Twice yearly, PyHC also meets in person for our biannual meetings, or at least we used to. With the COVID-19 pandemic, that changed a little bit. But hopefully we can get back to that soon, being in person instead of all virtual. But these meetings are open to seasoned open source heliophysics Python developers and newcomers to the community alike, both newcomers to heliophysics, newcomers to Python, people who are looking to transition to Python and so forth. And at those meetings, we discuss a variety of different things. We have updates for projects. We hold tutorial sessions, for example, how to, use Conda Forge, pip, those kind of things. We have hackathon sessions where people can actually work with the developers within the community and try to fix a problem or add a new feature or so forth to packages within PyHC. And we have discussions around relevant topics to the community and so forth. And as of this year, which I'll talk more about later, we held a PyHC summer school. This was obviously the first of its kind. And the goal was to introduce core PyHC and some other highly used PyHC packages in the context of leveraging them for scientific research. So as far as the PyHC umbrella goes, we've identified several projects within the heliospheric and space weather community, and we've organized them all on our PyHC website page under the projects webpage. There's 70 plus projects at this point underneath that umbrella. We have it separated into two different categories at the moment. So there are the core projects, which have a wide range of functionality within their area, and all adhere to the PyHC standards, which I'll mention in a moment. But those include like Plasma Pi, SumPy, PySpeedS, SpacePy, PySat, and more recently, we've added on Komodo and Happy, and you can find more information about all of those projects at that link that I showed here. We also have then a list of other projects. So these are still important to the community, obviously, but they're more focused in nature. Perhaps they really address a specific need for a specific mission or so forth. And the domains covered by all the packages that PyHC has gathered in science include solar, heliospheric, geospace sciences like magnetosphere, and then the ITM physics. And as far as software capability goes, there's a lot of different things that our packages cover, including modeling, especially with like Komodo, machine learning, plotting, wrappers for other libraries, CDF writers, and so forth. And if there's ever a project or a need that you identify that we don't have a package that addresses, please feel free to reach out and let us know. We are always looking to add new projects and capabilities to the community. So the leadership team includes myself. I'm the lead for PyHC and the principal investigator for the NASA grant that helps fund the leadership activities. That grant also funds our tech lead, Sean Polson, who also works with me at LASS. Our NASA Goddard Space Flight Center point of contact is Aaron Roberts. And of course, we have those core projects and leaders therein who help us steer this ship and make decisions for the community. And finally, these projects all have to follow a set of standards that we came up with. So a little bit on that. These are based on the AstroPy standards, if you've ever heard of that package before. And this was selected by consensus of the whole community at our fall 2018 meeting. I believe that was our first meeting that we ever had. So that's comprised of 15 different standards. You can see the listing here. There's a bit more of a detailed view, which I'm not going to read all of this out to you all. If you're curious to see more, that's in the paper that was just recently published this year. I'm lead author on it, and there's several others within the community who are on it with me. It's open access, so if you're curious to see it, just let me know. But yeah, we have kind of a few different groupings of standards for all of our projects. For example, Python 3, we want everything to be, compatible or working towards being compatible with Python 3 since Python 2 has been, retired since. You have to make sure there's testing, both unit tests, integration tests, and so forth. Documentation's a big one, and we're constantly, we're asking projects to get even better about that. But we want to be sure that anyone could come in from the outside and see these projects and understand what's going on via documentation and so forth. And of course, one of the biggest things for us is that code has to be made available and developed publicly. We're an open source community. If a project wants to join, but they're not yet open source, we can work with them to figure out how to get them to that point, but so forth. So those are our standards. And like I mentioned, all of our projects and information are organized under the PyHC website, which is just heliopython.org. We have several examples of how to use our packages. We're constantly working to try to get even better examples up on that, on our what we call our gallery page, especially examples that show interproject work and so forth. We have a blog that is a little quiet at the moment, but we're working to liven it up a bit with time. A documents page that includes those standards that I mentioned earlier, some annual reports, quarterly reports, that kind of thing. Our meetings tab is a pretty big one. We have a link to our biweekly telecons on that and past information on all of our past biannual meetings and so forth. And then the rest are kind of self-explanatory. Yeah, if you go to our projects page, this is what you'll see at the top. We have our core packages and then our other packages listed underneath it. And we have the grouping of standards for the projects listed here. And we have asked all of the projects to basically grade themselves against our standards so that people can see, how up to date these packages are, how much do they adhere to our standards and so forth. And it goes off of like a traffic light system. So green is good, adhered to everything, orange needs improvement, and red would be not meeting the standard criteria. And all of our core packages work to really meet that all with green. So like I mentioned, we have our examples page, the PyHC gallery page. It's currently in development to be transitioned to kind of another way of looking at the whole page, but that hasn't happened yet, so I won't go too much into detail on it. But as you can see, it's needs to be more populated at the moment, but if you were to click on each of these links, it would take you to, a Jupyter notebook of all the code there, and you could run it there in the browser, or you can download it to be run on your own laptop. So that was a bit of an overview of PyHC as a whole, but PyHC has a lot of activities that we also do that are not just, meetings and telecons. So we're partnered with the COSPAR ISWAT team. So COSPAR is the Committee on Space Research, and ISWAT is the International Space Weather Actions Team Initiative. And specifically, the one that PyHC is involved with the most is the 0206 team, or at least as far as PyHC leadership goes. And that's the coordination and collaborations of Python libraries and tools for ISWAT. The leads on that, there's Arnaud at ESA, Aaron again from NASA, and of course myself. But the goal of this team was to perform an inventory of all PyHC libraries related to heliospheric and space weather and put all those links on the ISWAT team page. We're also working, across all the various ISWAT teams there are to list and improve accessibility to various space weather services, identify incompatibilities and gather needs of groups for data analysis, visualization, or model data comparison. And the reason I bring this team up and the fact that PyHC is partnered with it is that we've done a few different activities with them over the past year or two that have led to a lot of really good outcomes, including an integration strategy workshop that we held that was partnered with NASA, our inaugural PyHC summer school, which I'll mention more later, and then the PyHC kind of overview paper, where we're at as a community, which I mentioned a little bit earlier too. So just a quick overview, we held an integration strategy workshop, like I mentioned. This was a NASA organized 2-day workshop. This was in late August 2021, so just a little over a year ago. Several people who are really involved in the community were on the committee, including myself. And the whole point of this workshop was to draw together key figures within the PyHC realm in order to discuss how could we as a community better advance our efforts to provide support for Python for the heliophysics research community. So we spent 2 different days working on that. The first day was just generating ideas. Where are our problem points? What are the priorities for technical work in the coming years, especially as we think about a theme of integration between projects. like stop thinking of all the projects as, just siloed one-off efforts that are working kind of, in their own bubble, and get everyone talking to each other. And then the second day we came up with various strategies for tackling these problems or blockers and so forth. And the results of this workshop was that we produced a public report of findings and observations to strengthen the space weather research information architecture. So that public report, you can find it at that link. Anyone can go and view it. There was also an internal NASA report that would help guide future recommendations and so forth. And the workshop helped PyHC determine next steps for integration and outreach efforts, including the summer school. So the PyHC Summer School was kind of a wild experience. We started organizing that December of last year, and then held it in May of this year at ISA in Madrid. And it ended up being a huge success. So this was our inaugural PyHC Summer School. We held it in partnership with ESA, or the European Space Astronomy Center, sorry, ESAC. And Arnaud Messon was our main point of contact and who we worked with leading up to the summer school. This was a free event. We really wanted it to be as open as possible. It was open to all graduate students, early career scientists, established scientists looking to transition to Python, and so forth. We held it over a week-long period at ESAC and also online. We offered remote participation Zoom for those who couldn't attend in person. And of course, we've also recorded and streamed all of the sessions that we held to YouTube. If you're interested in seeing those sessions, those recorded sessions, just let me know. I can get you that link. I think it's also linked on our PyHC website. But yeah, it was a big success. And the motivation that we had for this whole summer school was that we wanted to help attendees learn Python best practices and get hands-on instruction for experts within the PyHC community, as people took a deep dive with tutorial, demos, presentations into our PyHC ecosystem. So the main goals of the summer school, though, was in general expose more, especially of the young and up-and-coming researchers, to Python-based and open source heliophysics and space weather software, specifically through the lens of PyHC and what PyHC has to offer. So we introduced, our PyHC core packages and other highly used packages, and we were working to create an understanding of, what are these packages about? First of all, how are they useful to you? So then we talked about how to use core PyHC packages and so forth in a research workflow, how the packages could benefit one's research, and then how to use a little bit on PyHC packages locally with just a little bit of Python best practices sprinkled in. Of course, another goal was to attract more developers and users to PyHC, because just having more people, having more eyes, having more backgrounds looking at all the code helps improve the quality of code and really incorporates the community into the development and has us be, not just a head honcho saying, here are our packages, use them, but creates an actual community feeling and, more discussion and interaction, and brings up more ideas for how to continue the community and move forward. Another big goal of the summer school was to develop a working shared Python heliophysics software environment. And we ended up partnering with NASA, and specifically Brian Thomas and Jeff Bradford and others who had been working on the HelioCloud project at NASA and elsewhere. I'll talk about that more in a little bit. And then, of course, like I mentioned earlier, or not earlier, we wanted to expose heliophysics researchers to cloud-based research approaches, which we did via the HelioCloud project, which, again, I'll talk about in a minute. The general agenda for the summer school, we split it up into 1 or 2 projects-ish per day. We covered all the core projects at first, and we also got an AstroPy representative to come and describe, AstroPy for heliophysics and the various components of AstroPy that are relevant, as a lot of our packages leverage AstroPy. And then on day 5 is where we included a little bit on Python best practices and so forth, wrap up. So we were really excited because we had been hoping, for this to be a bigger event. We started with modest goals of hoping there would be, 50 people to show up, but we ended up getting just shy of 500 people signing up. And we had participation from multiple countries across North America, Europe, South Central America, Asia, the Middle East, and Africa. And a lot of these, as you'll see in a second, were students. So we were really excited about that. Around half to 75%-ish, I'm pretty sure. If you look at that graph there, we're made up of either undergrads, graduates, postdocs, or some kind of, early career professional. That was really exciting because that means we're targeting the next up and coming generation of researchers within the field, which means that we're getting more people early on to think about PyHC, think about open science in general and how our packages could help in that. So that was really exciting. And it was interesting. The majority didn't have much programming experience, probably as a result of being, mostly students. So it was cool to get, the in on people as they were really starting out with programming, with research and so forth, and get them to think about incorporating PyHC packages into their process. So the overall results from the summer school was that it was a really successful first rendition. This goes on a scale from 1 to 5, of 1 being not satisfied, don't agree, to 5 being very satisfied, awesome. So we asked questions in an anonymous post-summer school survey, like, how satisfied were you with this full experience? And people were really happy with it overall. And people were likely to recommend, a future PyHC summer school to friends, colleagues, and so forth. And they were really content with our content. So people felt overall that the content was pretty relevant, and there's a couple of views of a little bit less, content, but that's probably a result of people being interested more in a couple specific packages, but we went over several packages over all the days. And then the quality, people were really content with what we had to give. So that was really exciting to see people not only, show up in mass numbers, both online and in person. We had about 50 to 60 people on site throughout the whole week at ISA, which was really great. But yeah, it was just great to see that people were happy with what we had to present. So HelioCloud, I wanted to bring that up really quickly. It was a really big part of our summer school. So the HelioCloud project works to create a working, stable environment of all PyHC packages, or at least for the case of the summer school, since this was their first, big test of the whole platform in general. They incorporated all of the PyHC core packages and the other packages that were presented upon during the summer school. So that allowed us to provide to students a container that implemented a default Python environment and removed that need to resolve what we so lovingly call, dependency hell in programming. So we beforehand went and made sure that all of the packages would work nicely together, that there wouldn't be, any errors that would pop up from dependency conflicts and so forth. And the HelioCloud project provided a community cloud-based platform, HelioHub, that used that container. So people just had to simply log on to a website, and then they would have access to HelioCloud and be able to just, see all the tutorials and so forth that were presented at the summer school right there in a web browser. And HelioCloud itself is a public open source software, very much in the spirit of PyHC and open science in general. It's hosted on GitLab. You can see it there at that link. Just a quick, snapshot of what students saw when they logged in. All of our summer school code was over here to the left. People could click in, see further. We had Python already installed, ready for people to use. So then people could go through and via Jupyter Notebooks experience various PyHC packages and see, how to use these packages and so forth. And thankfully, people were really pleased with this HelioCloud platform, which meant that Brian, Thomas, Goddard, and the whole team working on HelioCloud at this point had motivation to go forward and keep improving it and add more PyHC packages and so forth. But overall, the platform worked really well. There were only a few minor issues that came up, during the summer school, some runtime issues, but that just meant HelioCloud itself is backed by AWS, so it meant using, different kinds of computing resources at times, just to be sure that everyone had access. It indeed provided a shared environment that included all the needed installations and notebooks for tutorials, so no one had to download or do anything crazy, and it worked fairly well out of the box. And students overall agreed with the above results that we saw and want to keep using HelioCloud, of a yes and maybe. There's over 75% of students interested in continuing to use HelioCloud in the future. So we're really excited about that. Obviously, Brian was excited about that. And they've been doing a whole lot of work on HelioCloud recently to continue to improve it. And eventually, we're thinking of working towards having, a packaging basically of all the PyHC packages that could just be deployed to a container like that. That hasn't come to fruition just yet, but it's a future goal of ours that we're working towards and actively working with Brian and others on HelioCloud, or I think they might be rebranding it to PanHelio. If you've ever heard of PanGeo, it's going to be a similar idea, but for the heliospheric and space weather community. So, yeah. As far as the summer school reviews, we asked students things like, what was your favorite thing about the summer school and why? And people had a bunch of different reasons that they really liked it, but there were a few that we were really content with because it meant that our goal was, communicated properly. So people found out, there are different tools in Python for space physics, but, through this summer school, they got to really know about the different Python projects and how powerful and useful they can be. And people like that, the presentations gave the proper insight into each project. So people would know what our projects are about, how they're useful, and so forth. The notebooks were a big success. People liked that than just having someone talk to them for hours straight about here's this project, here's what it does, and demoing. And it was great, they thought, to get explanations from people who were actively working on these projects themselves to come and talk about the projects. People were happy with HelioCloud. Again, you didn't have to worry about installation needs, dependency needs, so forth. And then in general, I really appreciate this comment personally because I agree. After 2 years of Corona messing up travel plans, being able to, meet with people in person and network in related fields was awesome. And then, this small seminar, we streamed our stuff to YouTube, and people really appreciated how easy it was to tune into that or to watch things after the fact. So some next steps for the summer school. We had several other topics that were requested by students for a future summer school, including things like how to run MHD simulations. A lot of people want us to dip more into the machine learning and deep learning realm of Python, and there's certainly some projects within the community and others we'd love to invite in that would cover those needs. People wanted even more examples of science being done with PyHC packages, in particular working with a bunch of packages together at once instead of just one at a time, because most people aren't just going to pull one PyHC package and use it. They're going to want to have a few different packages that work together to create an end result. And then some more in-depth explanation of best practices for programming. Perhaps in the future we'll have that as a little separate training before the summer school, but people did appreciate having that. So for future summer schools, we're thinking of continuing doing this on a biannual basis, since the first rendition this year was so successful. So the next one will be 2 years from now in 2024. We had initially thought perhaps, we'll make our own 2024 solar eclipse PyHC summer school event. And then we realized there are already a lot of communities working to do that exact thing. So we've pivoted a bit. We're going to be submitting a session proposal to TESS, which will be held in Texas in 2024. The idea is that hopefully, we can have a bunch of PyHC packages working together to visualize different aspects of heliospheric and space weather physics. So we would have some packages and cool visualizations running before the eclipse happens, and then everyone will go outside, see the eclipse, be wowed and awed by it, come back inside, and then we could look at visualizations of various components and see how the solar eclipse affected things. So then we would take all that information and then use it at our actual PyHC specific summer school later in the summer. So we're really looking forward to that. Look forward for more information on all of that. And we might combine it in the future with some biannual spring meetings, so you can hear updates on projects as well at the summer school. And then of course, we're looking to incorporate feedback from this year's students. So that was our summer school, and that was the second of 2 activities I'd mentioned in the PyHC ISWAT collaboration realm. And the third thing was that as a result of all the activities PyHC has done recently for the space weather and heliophysics community, as well as with the summer school work, we wanted to put together an overview paper and to talk about, the current status and future outlook for the community. So that's what this whole paper was focused on. And this was in the ISWAT realm. So ISWAT has several different papers that they're working on in what they're doing. There's the ISWAT various individual team papers, which is what this kind of paper was. There will be a cluster paper. So like our team was a part of the O2 community. So we'll be combined with, I think it's 7 or 8 other sub teams to then have an overall paper, and it keeps going up. But the layout of this paper was in general to think about how has PyHC realized the components of a heliophysics framework put forth initially by Angeline Burrell and others in 2018. And then we gave suggestions for advancing PyHC's efforts, including, how can we improve our information architecture, understanding of information within PyHC, and how PyHC connects to the broader community. We wanted to figure out how we could, grow our community project sustainability and usage, and came up with some ideas for that. How do we nurture the social component of PyHC, the community part of the whole thing? Because we're more than just software, we're also the people behind the software, the people using the software. So how can we continue to make this an active and burgeoning community and keep it going for future purposes? We also thought of some ideas for how to improve PyHC package integration. And then, of course, Python isn't the only programming language out there, but it certainly is widely used. So we talked about some ideas for non-Python library considerations. There's a lot of intensive calculations, simulations, for example, run in languages that aren't Python. So how can PyHC help bridge that gap there? And then we, ended the paper with talking about advancing PyHC's mission and strategic goals through the lens of helping better integrate PyHC into the broader heliophysics and space weather community efforts. So if you're interested in seeing that paper, it does talk a bit about the summer school therein as well. It was recently published to Advances in Space Research, one of their special issues, and it's open access because we're an open source community. So of course, we don't want to hide you behind a paywall in order to read our paper. So the next step in this process, as I mentioned, is helping contribute a little synopsis of this paper to the larger cluster papers that tie together all the various teams under ISWAT. And then some upcoming PyHC activities in general, not just ISWAT specific in the next year. AGU is coming up quickly. I think we have less than a month until at this point, which is kind of crazy. But PyHC has 3 different sessions at AGU this year. The in-person poster session, oral session that I mentioned, as well as an online poster session for presenters who could not make it in person. So be sure to check us out if you're registered for AGU and are wanting to hear more about our community and efforts therein. We also have our biannual meetings. Of course, the fall 22 one just wrapped up. We had it at the beginning of November. But if you weren't able to come but are interested in seeing what we talked about, you can go to the meeting webpage. It's just heliopython.org meetings fall 2022. We record all of the tutorials, discussions, presentations, and so forth. And we've put them up on that webpage for viewing. You can also go through and see what the agenda was. There's going to be a meeting report generated from that and so forth that will also be put up on the website. And finally, it looks like we'll get to have a hybrid meeting next time. So look out for more information on that, likely to be held here in Boulder, Colorado at last. And if you're looking to connect further with PyHC, the first stop I would suggest is going to our website, heliopython.org. You saw a little bit of a preview before, but there will be all the upcoming telecon and meeting info on the meetings page, PyHC packages info on the projects page, and so forth. And if you'd like to be reminded for these upcoming telecons, meetings, and other community relevant topics, please feel free to join our PyHC mailing list. It's open to anyone interested. To get on that, there's instructions on our webpage under the contact webpage. We have a few different chat rooms also. Recently, we created a PyHC Slack space. So there's a link to join there. For some reason, Slack makes it so you can only share a link that's live for a month. So that one will expire on the 17th of next month. But if you're interested ever in joining, just feel free to drop me a line with that email that you see there. We also have a Helionauts chat room, but that requires an invite as well. So to get that, you would go to the login page at helionauts.org. And I believe that is the end of my presentation for the moment. So happy to take any questions about the presentation, about PyHC in general, and so forth. And thank you for your time and attention.
Thank you, Julie. This is a very large project and initiative. I'm glad someone is leading it.
Thank you.
We have a question, a comment, and then I have a question to follow up from it. The first one comes from John Hadusik. Do you know of similar efforts from other programming languages or that are language agnostic? As much as I love Python, it's not a practical option in some environments or applications like parallel computing, embedded systems or web browsers, and the community and standards aspects would still be valuable without being tied to Python. Lynn agrees with this. He's from his comment, I'm going to call him a diehard IDL fan, or he's hooked to IDL, having written more than 1.5 million lines of code in it.
It's not so much of being a diehard fan. It's more of I've tied my anchor to the ship, and whether or not it's sinking is up for debate. But I've invested time.
That was a poor analogy.
Yeah.
And then just to follow up on that, like, is it possible just to expand PyHC to include code from IDL and MATLAB, given that there is so much legacy there for our community?
Sure. So first comment on the IDL front. LAS was actually the one to create and come up with IDL back in the day, which is funny because now we're trying, to slowly move people away from that over time. But yeah, I guess to address one of the later questions first, we're actively thinking about, how can we help work with this legacy code? Is it enough to have other, programming languages resources listed on the PyHC page and acknowledge, this isn't Python, but this is some widely used code within the community and so forth. Do we think about, trying to get funding to create Python wrappers so that people could use that? So that code doesn't just become obsolete and only working for those who work within those other programming languages, but, everyone could get access to it one way or another. There's maybe some thoughts in the future, like what I'd mentioned with having kind of a deployable PyHC package that we could put forth to community. If we put something like that up in a HelioCloud platform, we could also then include the other programming languages they're in and the packages that they have. Maybe there could be some kind of interface that's completely language agnostic that people could work with, and so forth. So it's something we're thinking about, but haven't necessarily made a whole lot of progress on yet, because this is stuff we've started thinking about really only within the last year or so. And we are but 2 people on the leadership team working to steer this ship at the moment. But we're looking to expand in the future, so hopefully we can tackle some of these problems more later on. Let's see, but there was a question first up. Do you know of similar efforts for other programming languages that are language agnostic? Not that I'm aware of, at least in the heliospheric and space weather community. PyHC is kind of one of the biggest efforts there, especially as far as pioneering open science goes, just because Python itself is open source. Yeah, I guess this is the best answer I have to that question at the moment. I wish I knew of a community that was really big and open, kind of like we were, that I could point you to, but at the moment, I'm not aware of that.
I think
IDL has a built-in Python interpreter now that will allow you to load and use Python in IDL. Oh, that's really cool.
Yeah,
true, but it doesn't really work. Oh no.
I've not tried it. I just know it exists.
I've tried it, and it complains about certain things missing, or some things not being properly compiled prior, or like it's missing libraries. I had all sorts of problems with it, so I gave up, tried to teach myself Python, and then there was so much duck typing just to open a single file. I was like, okay, this is getting out of hand. So I asked for a different file type, and it took me 5 minutes to open it. So that was the extent of my diving into Python.
With regard to John's question, the TOPS initiative is quite big, and it's supposed to be quite big for the next few years. That is towards open science, I believe. And while some of it is just regarding having open access to journals and stuff, I think there will be a large computing aspect to it. And so hopefully that'll mean in the future that code in general, regardless of what you're writing in, if you're being funded by NASA, will be required to be open source. So that is hopefully will be somewhat of a new mandate, and that will create a somewhat agnostic program, but it would still likely be managed by authors themselves. So authors would just be required to have their code on GitHub or GitLab or something. So.
Yeah, Ryan McGranahan's been really involved with the whole TOPS initiative. He presented on the TOPS initiative itself at our recent PyHC meeting. If you go to the meetings webpage, you can find that. I believe he presented on day one, if you wanted to go watch that. But I know he's also presented this kind of information on TOPS at a lot of other places too. So there's a lot of information about that out there, and there's definitely a big programming, push involved to be open source there, like you were saying.
All right. Well, thank you, Julie. We really appreciate you talking on the Thanksgiving week.
Of course.
So this will actually be our final seminar for the year. We'll be taking a break for AGU preparation, as well as the winter break. And so we'll be coming back in the new year with a new agenda and a new calendar of talks. So I hope everyone has a wonderful Thanksgiving, and I hope everyone enjoys AGU if you attend, or the winter break if you don't. So have a wonderful week.
Thanks again.
Thank you.